All right, let's get right into it. We are about to go on a grand tour of the cosmos, one that's going to challenge pretty much everything you thought you knew about the universe, from our own planets to the very edge of reality itself.
So let me ask you this. Think about all those classic pictures of space you grew up with. The planets, the moons, everything. Well, it turns out our understanding is changing so fast, a lot of that is already out of date.
For instance, take Saturn. You know, its magnificent rings, the symbol of the whole planet, well, they're not forever. They are literally raining down onto the planet's surface and could be completely gone in about 100 million years. Now, that sounds like a long time, but in cosmic terms, that's just a blink of an eye.
And what about our moon? The quiet, geologically dead rock we've always imagined. Turns out, not so much. India's recent Chandrayaan-3 mission actually detected a lunar quake, a real tremor on a world we thought was perfectly still.
And that deep, brilliant blue Neptune we've seen in every textbook since we were kids? Yeah, that's not its real color. It's basically an illusion from how the first images were processed. The reality is much, much paler. So let's start peeling back these layers, starting right here in our own cosmic neighborhood.
So our first stop is right here, our very own solar system. And you can forget those static models from science class. Our neighborhood is a place of constant, fascinating, and sometimes bizarre change.
Okay, so India's Chandrayaan-3 mission was a huge deal. It didn't just land on the moon. It touched down on the unexplored, super tricky South Pole. And the things it found are totally rewriting what we know. First, it confirmed there are lunar quakes, probably from things like meteor strikes. Then, it found sulfur, which is a big clue to the moon's volcanic past. But maybe the coolest thing for future astronauts, the soil is an incredible insulator. The temperature on the surface can be a scorching 140 degrees Fahrenheit, but just a few inches down, it plunges to 14 degrees. That's a game changer for building future moon bases.
Right, back to Neptune's color. For decades, we've all seen that deep blue image from the Voyager 2 probe. But it turns out those images were processed to make features like storms really pop. When scientists reanalyzed everything with modern tech, they got the true picture. Neptune and Uranus are actually almost twins. Both are a very similar shade of pale greenish blue.
Okay, let's head a little farther out now. We're going to the gas and ice giants. These are planets we've known about for centuries, but believe me, they are still throwing us some serious cosmic curveballs.
Now this is one of the strangest things in our entire solar system. Saturn's North Pole has a storm that is a geometrically perfect hexagon. It's colossal. You could fit 2 Earths inside it, and it's been raging for decades. So how is that even possible? Well, scientists think it's caused by something called deep thermal convection, where heat rising from inside the planet creates this incredibly stable, 6-sided jet stream. It is a weather pattern unlike anything anywhere else.
And this just shows how active these planets are. The very rings that define Saturn are being eaten by the planet itself. Particles of water ice get charged up by sunlight, then they get snagged by Saturn's magnetic field and just funneled down into the atmosphere. This ring rain is draining the rings so fast it's equivalent to an Olympic-sized swimming pool of water vanishing every 30 minutes. It's just wild.
All right, let's zoom out now, way out. We're moving beyond our immediate neighbors to tackle the biggest question of all. Are we alone? This question is driving some of the most amazing science, looking for everything from a new home for humanity to signs of vast alien empires.
So when we talk about colonizing other worlds, you probably think of the moon or maybe Mars, but take a look at this. Saturn's moon Titan is a surprisingly strong contender, and the reason why is its atmosphere. It's incredibly thick and dense, even denser than Earth's, and it acts as a perfect natural shield against deadly space radiation. That's a massive problem we'd have to solve on the moon or Mars. Sure, its lakes are liquid methane, not water, but Titan really forces us to expand our definition of what a habitable world could be.
So if there is intelligent life out there, how would we even classify it? Well, there's this fascinating idea called the Kardashev scale. It ranks civilizations not by their technology or culture, but purely by how much energy they use. A Type 1 civilization controls all the energy on its planet. A Type 2 controls its entire star. And a Type 3, well, they command the power of a whole galaxy. And us? We're not even a Type 1 yet.
So, how would a Type 2 civilization actually capture all the energy from its star? Well, they might build a Dyson sphere. Now, this probably isn't a solid shell, but more like a giant swarm of collectors orbiting the star. So how could we find one? Well, a structure like that would block a star's visible light, but it would glow like crazy in infrared from all the waste heat it's giving off. And here's the really exciting part. Powerful telescopes like the JWST are actively searching for exactly those heat signatures right now. The hunt is on.
All right, we're shifting gears from the search for life to the very fabric of reality itself. We're now entering the realm of cosmic monsters, places where the laws of physics as we know them are pushed to their absolute breaking point.
You know, it turns out black holes come in more flavors than we thought. We knew about the small, stellar mass kind and the supermassive giants at the heart of most galaxies. But recently, we finally found the elusive missing link, intermediate mass black holes. And even more chilling, we've confirmed that rogue black holes are real. They get ejected from their home galaxies and just wander silently through the cosmos. Imagine one of those drifting through our solar system.
But here's where it gets really weird. The exact same math that describes a black hole also allows for its complete opposite, a white hole. Think about it. A black hole is a place where things can only go in. A white hole is a theoretical place you can't enter from the outside, but where matter and energy violently erupt out. It's literally a black hole playing in reverse. We've seen plenty of black holes, but a white hole? That's pure theory. Or is it?
And this leads to a truly radical, mind-bending idea. What was the Big Bang? A singularity that just appeared? What if it was actually the eruption of a single colossal white hole? A cosmic fountain that spewed out all the matter and energy that eventually became our entire universe. It's a theory that could connect the beginning of our universe to the end of another one.
So that brings us to our final destination, where we're going to look at a concept pulled straight from science fiction that actual physicists are taking very, very seriously. Are the dreams of interstellar travel just fantasy, or are they a preview of our distant future?
So the Alcubierre warp drive is basically a loophole in Einstein's theory of relativity. You can't travel through space faster than light, but what if you could move space itself? Think of it like a surfer on an ocean wave. The surfer isn't moving faster than the water, but the wave carries them across the ocean. A warp drive would do the same thing, creating a wave of spacetime that compresses space in front of the ship and expands it behind. The ship just chills inside a bubble, going along for the ride. So, if it works on paper, why don't we have one? Well, there are a few hurdles. First, you'd need a substance with negative mass, so-called exotic matter, which might not even exist. You'd also be totally cut off inside the bubble, so you couldn't see where you were going or stop it. And maybe the biggest problem, the front of the bubble would accumulate a deadly blast of radiation that would basically vaporize your destination when you arrived. So yeah, there are a few kinks to work out.
And that leaves us here, with this one last thought. Concepts like warp drives and Dyson spheres, they sound like pure fantasy today, but 150 years ago, so did flying to the moon. As we keep unraveling the universe's biggest mysteries, are we just discovering the basic principles that will one day turn today's science fiction into tomorrow's reality? Now that's a question worth thinking about.